official other.
We're labeling it just as 10 newtons and not with some other letter.
Whichever way you want to do it.
And there's no tension, so.
All right, so let's see. Gravitational, normal, other, no tension, and friction. All right. So force diagram done. Which way will this thing accelerate if it's going to accelerate?
To the right.
I hope so. So acceleration, again, this is not part of the force diagram, and just a note. Coordinate system, coordinate axes,
We'll make the right positive.
and up.
Positive, yeah.
If you don't like what she's doing, you need to speak out. I hat and J hat. And decomposition.
Nothing needs to be done because it's not like.
Okay. All right, equations of motion. How many equations of motion will we have? Somebody just say it?
2?
Yes.
Should be 10 newtons minus friction equals 4 kilograms times 9. Is it? Oh, times its acceleration, which we don't know.
Right. Yeah. Please don't put 9.8 there.
Yeah, sorry.
Out there. And the other one?
Should be.
Normal minus 4.
Equals 4 times negative 9.8.
0.
0. Don't forget, we want one of our equations of motion to be 0. Now, sometimes you can't help that, but in a problem like this, one of them will be equal to 0.
Remind me why it would be the acceleration for the force due to, well, we already have weight. That's
You have to think about what is the acceleration in that direction. So vertically, how's it accelerating? As it's pushed this way, is this thing gonna come off the ramp or dig into the, or off the surface or into the
I
surface?
guess it's not, no, yeah.
Yeah, there's not any change in velocity horizontally.
Right.
So we can assume that because we're trying to find the acceleration horizontally, that vertically the acceleration has to be 0.
You make it sound like we can will reality.
Yeah,
We
like
just-
just forget about gravity, period.
I think we just know from the.
We're not
that it's not
we're not willing it away, but just from the physical nature of the problem,
Right.
it's reasonable to assume that there's no vertical acceleration.
Okay.
So that's why we're justifying it based upon
Right.
life experience.
Cool.
If in doubt, we would have a different acceleration here, so this may be like A1 and A2. But then we'd have to have some other relationship involved here. What is up?
Yeah, so for J-hat, why are we subtracting weight if it's, like, I don't understand how that would be negative.
All right, so Brooke said up positive. So when you're doing the equations of motion, you look at what are the forces in the positive direction? Well, that's y. Minus the forces in the negative direction. That's why it's minus w.
Okay, so we're only looking at the block, we don't have to worry about like the forces on the ground?
No.
Okay, I was thinking that.
Yeah, because there are a lot of forces acting on the ground, and I don't want to get into everything that we haven't included. Yeah, because if we brought the ground into it, then it suddenly makes a difference about what's causing this, is whatever's causing that touching the ground. And so that just gets way complicated real fast. Ultimately, the question is, what's the acceleration of the box? I didn't state that explicitly, I just said, what's the acceleration? But it's the acceleration of the box. And so we will be using just the forces acting on the box.
Okay.
All right, other questions at this point? Brooke?
Could you say or write out what the formulas are for the equations of motion, just so I can like put them down? Because it makes sense, but I don't
ultimately, that's the basis of it all.
Okay,
Later on, we'll add this is the basis for equations of motion when it's all linear.
okay, gotcha. So-
When we start things rotating, the formula is, this is the jump ahead several chapters. And that's based on this.
Okay, yeah, I don't wanna worry about that yet.
Yeah, this is for rotation.
Okay.
Is that what you're looking for there?
Mhm,
Okay.
thank you.
All right, substitution. We have to establish first, because I didn't state that it was already moving or say just assume it's moving. We have to figure out, is it moving at all? So step one, once you get to the substitution phase, is assume static. You assume it's not sliding. So assume static. Actually, maximum static. So my substitution here becomes 10 minus mu sub s times y is equal to 4a. The second one, I'm going to go ahead, this is equal to 0 here. We have a formula for weight, which is mg, and so I'm going to bring it over to the other side, so I have y equals mg. Some students know that weight equals mg, and then the force diagram they'll write mg instead of w. It's not inherently wrong unless the problem says, make sure the answer is in terms of w. Now we substitute, we're going to take this mg and stick that in for y. So I have 10 minus mu s mg is equal to ma. And we're solving for acceleration, so acceleration is equal to 10 minus mu s mg divided by 4, which is 10 minus 0.3 times my mass, which is 4, times, let's make it on Earth, 9.8 divided by 4.
Is the 9.8 gonna be negative?
No, g itself is always a positive number.
Okay, makes sense.
The negative aspect has already been taken into account.
Okay.
And so we get something around that. I think slightly more, 11 point something. Or am I off there?
It's in total or just the top?
Okay.
The top is 10 minus 11.76, which comes out to in total, yeah. It comes out to negative 0.44.
Units?
Newtons? No, meters per second squared.
All right. So here's the big question. What's the acceleration of the box?
0.
Ian?
Is it 0?
It is 0.
Because we assume
Because this
static.
is negative?
Yes.
No, we didn't max out the friction, so it's not moving.
We assumed maximum static friction, and we did not exceed the maximum static friction.
So if that number was positive, it would be moving.
Yes. So, because this is 0.44, negative 0.44, what this means, if this were physically true, if this actually had physical meaning here, that means I'm gonna push it in the box that way, and it's gonna accelerate in the negative direction. And if that's the way nature worked, we'd all be in trouble. Here, let me push the car out of the way.
So, is it, if that was 0.44, would that be accelerating in 0.14? No.
All right, so all right, so for right now, the acceleration is 0 because we did not exceed maximum static, it's
Right.
not moving. All right, so let's set the situation up so that it will move. Through the magic of an eraser, we add a little oil down here, change the surfaces. 2.2 and 0.1, and pick the wrong marker there. So now, we still go through the exercise, hopefully I've reduced it enough that it'll work. But we still assume static friction, or maximum static. And I recognize I have the beauty of just erasing a couple numbers here, whereas you potentially are rewriting everything. But I guess it is on being recorded. So now, what is my maximum static here?
7.84.
And so therefore,
0.54.
so we see that we have a positive acceleration, and we were expecting a positive acceleration. Therefore, it is moving, and therefore, that's not the acceleration. Because once we establish that it is moving, it's kinetic. And so we change that. And so this now becomes whatever half of that was, the 3.94. No, 2. So somewhere around 1.5,
Yeah, 1.52.
5, 2,
2.
and that's the acceleration.
So what was the significance of 0.54 meters per second squared?
The fact that it was positive told us that we had overcome the static friction.
Okay. So we would need to do both pieces. One to show that we've overcome the static friction, and then one to actually show what the acceleration
Yep.
is.
Now, on a test or quiz, you can gamble. You could go, let's just assume we're gonna overcome it, and just jump straight into the kinetic. And if you guess wrong, then well, you'll pay dearly for it. Now, you are in some fortune is that I always hated I have to work the problem twice problems. Or I don't know if I have to work the problem twice, but I have to go through this. Doesn't mean I haven't done it before, but just be aware of the really complicated ones. I tend not to have you do them twice. It would be on the simpler one. Brooke?
Question, so will we ever run into the maximum static acceleration being negative and the kinetic friction being positive?
Yes, that is possible.
Okay, that's why you have to work both.
Yeah. If the static is, if you get negative with the static, then it really doesn't matter what the kinetic was.
Yeah, exactly. Cause I would hate to just go straight to kinetic and get a positive number and be like, okay, it's moving, and then.
Yeah, and that's why it's gambling. Other questions?
Yeah, so why, like, how did we determine that the U sub, if I'm saying it right, U sub S
Uh-huh.
is 0.1?
Because it was given.
Oh,
Yeah, you're either given the value of mu or you're asked to find it and you're given all the other information.
so if you were given, well, if you weren't given mu, then, no, if you were given mu, then, what am I trying, okay, if you weren't given mu, then we would have to solve for that and we'd be given acceleration.
Yeah, or somehow enough information to find acceleration.
Okay.
Would the problem be different if you had not given us that the initial velocity was 0 meters per second? Like, was that superfluous information?
No, the fact that I said it started at rest meant we had to do the static bit. If I gave you a value other than 0, then you know automatically it's moving, therefore you can skip static completely.
I see, okay.
Because then a negative static value is meaningless because, well, it's already moving. Other questions? There is a question on that lab that I guess is, well, not due next Wednesday, the Wednesday after that. rolling friction. I talked about static and kinetic. Rolling friction, it's sort of a combination of the two. When something rolls, it's not a perfect roll. It's not like something rolling is only touching the surface in one spot. There is some rubbing going on, and there are some places in rolling where the object's not moving, or the wheel is not sliding against the surface. And so there's also rolling friction is equal to coefficient of rolling friction times the normal force. It typically is not, actually I've never tried to look it up. So let's say, when you type in coefficient of friction, table of coefficients of friction, they'll give you mu sub s and mu sub k, or I guess potentially just mu, but they aren't gonna give you mu sub r. The idea on that one is if I take a ball and I roll it on this carpet, it will stop rolling at some point, or at least slow down. So what's causing it to slow down? Well, there's some friction. And so that's what's going on here. Yep.
Just considering the mu sub everything versus the just normal mu, are we ever gonna use the attraction model? Or are we
No,
just-
I bring that up because at some point, there's a slow transition in textbooks, and I don't, to me, the jury's still out, but just because I've been dealing with the nook and cranny for so long, it's possible that at some point in your lifetime, the textbooks won't be doing the use of S and use of K anymore. You know, sometime in the next 50 years, it'll change or not. And I throw the number of 50 out there. When it was finally, there was an experiment, which is considered now the experiment to show that there's no ether in outer space, that outer space is a vacuum. That experiment was done in the 1890s, and I have a textbook from the 50s that still refers to ether. So it takes a while. I've been told American textbooks take longer than European textbooks.
Wow.
They gotta do all their fact checks.
That's right.
Takes about 50 years though.
You know, of course it's a conspiracy.
Nah,
Put out
what-
by Big Friction.
You guys didn't do this experiment, you just said you did. I gotta look into this. It's gonna take me my whole life.
I tried that experiment, it didn't work. So we're gonna sort of do a variation of finding use of S here. So let's give a mass of M. And what I wanna know is at what angle, or I wanna find use of S, that basically is it. So in essence, what I'm doing here is I have two surfaces, I'm gonna tilt one of them, and I'm trying to figure out, you know, the more and more static is acting on it, more and more static is acting on it, and then more and more. So the question is, what's the relationship between my tilting it and actually finding the value of mu sub S?
So we're trying to figure out the maximum static friction.
The mass is irrelevant, so that's why I didn't give you a number.
Okay.
You can make up, if that disturbs you, make up a value. And just not zero. I started speaking before you, I think you finished your question. Did I actually answer it?
Yeah, you
Okay.
did, thank you.
All right, so we have weight acting down, normal force acting this way, and static friction acting this way. So there's the force diagram, acceleration. If it accelerates, it will accelerate down the ramp. In reality, we don't want it accelerating, sort of, and that's something that I'll talk about in just a moment. But acceleration would be down that way if it existed. What I'm getting to is a justification for why I'm setting my coordinate system like that. It ultimately, I think, will be easier, especially since we don't have to break one vector up into its components and not the other two. Was somebody about to ask a question? Which I think was grammatically horrible sentence on my part. All right, we've broken weight up before. We have normal force acting away from the ramp, friction acting up the ramp, and then W sine theta down the ramp, W cosine theta into the ramp. I'm gonna pause here. We've gone through that before. However, if you're still unclear about where the sine and cosine come from, I'll be glad to go over it again.
Yeah, I'm gonna need you to go over.
We're breaking weight up, and that's some relationship with theta. So I'm just gonna take my physical diagram right here, or this represents the physical situation. Weight is acting down, and that's what I'm breaking up. Part of it is down the ramp, part of it is perpendicular to the ramp. In other words, part of it's in the I hat direction, the other part is in the negative J hat direction. If this is theta here, if I look at this bigger triangle, that means that this must be the complement of theta, because this big one is a right triangle, that is a right angle there. So this is what I'm gonna label as theta prime. And now looking at the smaller triangle here, the one in black, that is also a right triangle. And if that's the complement of theta, this has to be theta itself.
Okay.
And so this down the ramp is opposite my angle theta, and so that's why this is the sine. All right. My equations of motion.
W sine theta minus static friction equals, give it this? We were not given
Just
this.
M, A,